Hello, everybody. Great to see you all here. Event 2022. Hope you're having a great time so far at the session. We know you've got the late night session tonight, so appreciate you coming out to spend some time with us. This is What's New in Amazon Athena. My name is Scott Rigney, and I'm one of the product managers on the Athena team. This session has a bunch of great announcements and updates on features that myself and colleagues have been hard at work building for you over the course of this year. And we're joined by a great guest speaker. In a little bit, we'll hear from Ofer Eliasov, who joins us today from Mobileye. Ofer is going to tell us about how he and his colleagues are using Athena on a really cool use case. So before we get into it, thanks again for joining today's session. Hopefully you got a lot of great updates for you. So today we're going to go on a bit of a journey through Athena and data lakes. We'll start with the core of Athena, which is our engine. And we wanted to start there because we have a lot of great announcements to share with you about all of that. Next, we'll hear from Mobileye on how they're using Athena as part of their machine vision systems for autonomous vehicles. It's a really fascinating use case, and we're really happy that Ofer could join us here in person to tell us more. And last but not least, we'll cover some of the announcements and updates on how you can bring Athena to your data, apply it to all of your data sources, spanning data lakes, external sources, and more. But before we do that, let's do a quick poll by show of hands. Is anybody here new to Athena? All right, a couple of you out there. So thanks for joining. For those of us who are new, we thought it'd be good to start out with a little bit of a refresher on Athena. So let's start off with that. Athena is an interactive query service that's designed to make it easy to query and analyze data in your data lakes. Athena is serverless, which means there's no infrastructure to set up and manage, and you pay only for the queries that you run. What customers love about Athena is how easy it is to get started. With the product being serverless and having no infrastructure to set up, it simply means you can sort of bring Athena to your data and start analyzing it. Athena is interactive and built for speed. Everything we do in the product is designed to help you answer business questions quickly and do that in a cost-effective manner. Athena is built on open standards, and that starts with our processing engine, which is based on open source technology like Presto. And with that comes support of multiple data formats like Parquet and Apache Iceberg, so you can get started with the data that you have today. Athena is also cost-effective. You pay only for the queries that you run, and you can save up to 90% using compression, partitioning, and converting your data into optimized columnar formats. We launched a few years ago here at reInvent 2016, and today we have thousands of customers spanning industries and of all sizes, ranging from startups to large enterprises, who've chosen Athena for a variety of use cases, including securities analysis and financial services, information security, where Athena is used to provide rapid response to security and insights on security events, as well as analytics in highly regulated industries, especially those dealing with sensitive data like healthcare. So let's go a little bit deeper to understand how customers are using Athena today with some of the common patterns and use cases that we see. First off should be a no-brainer, and that's interactive analytics. And with this, what it means is analysts, data scientists, and data engineers send SQL queries to Athena and often get responses back in seconds. Another is business intelligence. It's a very common and popular one for Athena. And with our drivers and SDK, you can plug Athena into your preferred business intelligence and applications, or SQL IDEs, like Power BI and Tableau. Data workflows are an interesting area for Athena. Here, what customers do is build what we like to call self-service data workflows using SQL that makes data available to other applications, teammates, or processes. For example, our integration with step functions, which we released last year, gives you a good, really easy to use, no-code experience to building these drag-and-drop data workflows. Many of our customers use Athena for a query layer on custom multi-tenant user-facing applications, often coming with a custom UI. And last but not least, machine learning. Machine learning, as you know, algorithms tend to benefit from diverse input data. And to bring all of that diverse data together, what data scientists often do today is build ETL jobs that move raw data from one source to another one, so they could ultimately join it together before feeding it into systems like Amazon SageMaker to run machine learning training and inference workloads. Athena provides up to or close to 30 data sources, so you can use Athena as a SQL layer to pull all that data together to provide a kind of common experience for creating those base tables for machine learning workflows. What all of these use cases have in common is that they're based on SQL. SQL is great. It's often one of the first things that analysts learn, and it's widely understood across both business and technical domains. One of the challenges with SQL is that many describe it as being not expressive enough to answer some of the more complex business questions that often come up. To get around that, a lot of folks turn to open source frameworks like Python and Spark to quickly find insights on this data. But what they quickly discover in scaling those products and frameworks is that it's really hard to do that in enterprise settings. Not only is it hard to get those frameworks to work, but it's also requires heavy investment upfront to optimize your infrastructure so that it is right-sized to serve your business needs while not breaking the bank. And all of those are reasons why we were really excited earlier today in Swami's keynote to unveil a brand new capability in Athena, which is Apache Spark. With Amazon Athena for Apache Spark, you can run interactive analytics quicker than you could ever before. And with that, you get the ease of use and speed that you've come to expect out of Athena. With this brand new experience, you can start interactive Spark applications in just under 1 second, which is pretty amazing. The product uses our AWS optimized Spark runtime, which is up to 3 times faster than open source Spark, which means you spend a lot less time waiting to provision clusters and wait for them to come online and produce the insights that you're looking for, and get to spend more time discovering insights from your data. To allow you to run those workloads on Athena, we've added a new experience in our console, a notebook experience, and that allows you to write Python code, run calculations in Spark, visualize your data, and a lot more. This is a really exciting new capability for Athena, and there's a ton of awesome capability there. Unfortunately, certainly too much to kind of go into the details on in today's session. So we recommend that you check out ANT208, which is a deep dive on the Spark announcement, and that's happening tomorrow. So be sure to check the session guide and sign up for that. Now, if you're sitting there wondering, how does this impact the SQL part of Athena that I probably came to learn about today? Well, don't worry, because we've got a lot of really great news for you on that front. And that all starts with our SQL engine, the latest version of which is version 3 that went GA just a handful of weeks ago. And as you've come to expect from Athena engine releases, V3 is providing faster queries and is more efficient at scans, which means you get better performance and lower cost for your workloads. One of the interesting things with this release is that we've rebuilt the way in which we pull components from open source. What that means is version 3 will provide you more current, more numerous, and more interesting features coming from the open source community with greater sort of regularity. The other big piece of news is that engine version 3 also incorporates Trino. Trino, if you're not familiar, is a fork of PrestoDB, which Athena version 2 is based on. But it provides a lot of the similar functionality, but there's some key differences across the products that kind of show up, and customers are asking to leverage some of the capabilities from the Trino variant of PrestoDB. So this version of Athena includes both Trino and Presto, and comes bundled with optimizations built by our team to scale those frameworks for use in AWS. So let's take a look at some of the benefits that are coming with version 3. Right out of the gate, you get 50 new functions, and that's going to help you expand the types of analytics you can apply to your data. We've made over 90 enhancements to existing functions, spanning query execution, memory usage, and how we process data, all to give you queries that run faster. What that means in our benchmarks is we're seeing about a 20% performance speedup compared to version 2, and some queries seeing up to 10 times faster execution in specific stages of query execution like planning. So really awesome benefits kind of in the performance domain. Best yet, you get all of that for the same price and with 100% functional parity between the version 2 API, and that should make it very easy to upgrade to version 3 today. As I mentioned, we rolled out V3 a few weeks ago and are happy to report that customers are seeing some of the benefits in their applications. Orca Security is one such customer who is using Athena within their machine learning-powered security event detection product. Ari Teeter, who leads R&D at Orca Security, shared this quote with us, and Ari has reported that Orca is already feeling the scale and performance benefits that come with version 3 and are starting to tap into that expanded feature set that's coming with the Trino kind of version of the SQL engine. So to speak more on that, as I mentioned, one of the highlights is the expanded set of analytics capabilities that come with version 3. For example, come a handful of new aggregation functions like T-Digest, which allows you to run approximate rank-based statistics with high accuracy. Another one, if you're doing geospatial analytics, are new and improved geospatial functions that help you bring location-based insights to your analytics programs. And also available are new operators like Match Recognize, which bring more performant pattern matching to use cases like fraud detection and sensor data analysis. Now, there's a special one at the top left of the screen, which we wanted to dive into a little bit further, because that's a brand new one for Athena, and that is query result caching. Before we get into that, some background. Many of the customers we talk with often describe using Athena in what we'll call multi-user applications. These are often applications like business intelligence, where multiple users are accessing Athena from the context of another application. Now, in this model, users send queries to Athena using those applications. Athena runs the queries and returns results via our API and drivers. And that sort of sets the standard flow of running queries on Athena. The challenge with this model is that as the number of users expands, what we tend to see is users sending very similar or oftentimes identical queries to Athena. With that comes added latency, which can add to reduce the time to insight on your data. And those repeat query executions can drive your costs higher. So that's why we were excited to release just a few weeks ago a caching feature for Athena, which we call query result reuse. And that was released just a few weeks ago, as I mentioned. With query result reuse, Athena automatically accelerates queries by returning the cache results of previous executions. And when enabled, queries using this query result reuse feature run up to 5 times faster and don't scan any data. So you're getting a lot of opportunity for performance and cost savings benefits out of that one feature. So to give you a sense for how that works and what it looks like, we'll take a look at a sample query here. Here we're doing a simple count of canceled flights grouped by day of the week. And in this first run, highlighted in the orange box, what you can see is that our query took about 3 seconds to process and scanned around 50 megabytes of data. So to turn on query result reuse, we just toggle the slider switch there. And then we can rerun our query. And what we see is the Athena is applying the cached executions to this query, returning the result in around 250 milliseconds. So huge speed up in terms of latency that users are going to feel the benefits of. And best yet, you see no data scanned with that query. So to make it easy to see when caching is happening in the system, we've added a few new views to the product, including the query history, which is shown here. And that's giving you a better sense in inspecting your query history on how frequently cache results are being returned. So that should make it easy to quickly diagnose and see what's happening in the system. So stepping back, query result reuse is available today, and it's built for Engine version 3. It's easy to use, requiring no changes in your SQL queries to get started. It's automated, meaning Athena automatically identifies the queries that can be accelerated and automatically returns the cache result for those queries without scanning any data. And then thinking back on those multi-user applications or contexts, it's really easy to bring all of these benefits to those users as well. For driver-based clients, it's a simple configuration change where you just enable the query result reuse behavior within the latest version of our driver. And for API-based clients, you simply specify it's a binary toggle whether or not to use query result reuse when submitting new queries. So between our new engine and features like query result reuse, queries are running faster out of the box with less need for a lot of that heavy query tuning of SQL queries that's needed up front. But for those of us who, and I know a few of you are out there, but for those of us who like to go a lot deeper into our queries and squeeze all of the performance out of them as possible, earlier this year we released a handful of new features in our console to make it easy to inspect your queries and really dive into their performance. That starts with visual query plans. So previously, before you ran a query, you could inspect a query using the explain SQL syntax. And what we heard from customers is that wasn't easy enough for SQL analysts who were using the console and wanted to get a kind of simpler experience for inspecting those query plans. So we've added a single-click visual experience for this in the Athena console. And to access the query plans for a query that you've got loaded into the console, you simply click the explain button, and that's going to take you to the query plan. Up next, you can choose between the distributed and logical plan for your query, and that's going to help you inspect the joins and other complex operations that are happening in your query. What's really cool is the experience is interactive, so you can pinch and zoom and sort of inspect individual stages of your query to learn more about what's happening at each of those stages. After you run your query, we now display some really useful runtime statistics and other query performance metadata. Here we see some key data, like the number of rows returned by a query, and that's really helpful for validating that your query is working as expected. You also see summarized performance data shown in the bar graph at the bottom, which encompasses all of the key stages of query execution, including query planning, queuing, and query execution. So that's all great, but if you want to go even deeper into how your query executed, you can click the execution details button, which is shown at the very bottom right, and that's going to bring you into the deep dive view of how your query executed on Athena. So here, the top node, just to orient you around how the information is displayed, the top node represents the last stage of your query, while the bottommost nodes represent the earliest stages. So you kind of think about it in terms of bottom up. The green bar in each of these nodes shows the duration in relative terms of the runtime for that stage. And what that allows you to do is zoom out and quickly see where your query is spending the most amount of time. And that should give you good insight as to where you can dig in to identify optimizations that will make your queries run faster. Clicking a node shows off to the very right really interesting and useful stage-level operator data that allows you to inspect the operations at each stage of your query. Now, if you're not using the console today and still want to do sort of analysis on your queries and how they're running and potentially in bulk sort of a use case, we also released an API, and that's the Get Runtime Statistics API to support that experience as well. And that's the API that's sitting behind all of the rich data that we're surfacing for the queries after they've run. So it's a really great API to check out. Query tuning is certainly a great way to get more performance at lower cost for your workloads. Another strategy we often recommend actually deals with the data structure itself. And that's really important because when dealing with big data, how you structure your data can have a huge impact on query performance as well as cost. To deal with this, we typically recommend customers use columnar data formats, partitioning, and compression. And when you use all of those together, you can save up to 90% on per query execution costs. Optimizing your data lake is a big investment. It's a really important part of the journey, as we'll learn in a little bit. So to hear more about that, I want to invite our guest speaker to the stage to tell us about the journey he and his colleagues are on at Mobileye to not only optimize their analytics workloads, but to bring about a really exciting future involving autonomous driving that'll benefit all of us. So, Ofer?
So hello, everyone. I hope you're having a great time here in the conference. Thank you, Scott, for introducing me. Like Scott said, my name is Ofer Eliasaf, and I'm a director of Mobileye's REM Cloud infrastructure. I'm going to provide an overview on Mobileye's autonomous vehicles, or AV, mapping technology called REM. We will discuss REM's data ingestion challenge and our need for a data lake. And we will then talk about our journey with Amazon Athena as our ingestion data lake. So why do autonomous vehicles need high-definition maps, or HD maps? Sometimes they are called AV maps or autonomous vehicle maps. As you all know, Mobileye is one of the world's leaders in the autonomous vehicles industry. Mobileye discovered that accurate maps are necessary in order for autonomous vehicles to operate better. The reason is that the vehicle needs to plan things like lane transition and do routing in distances where its sensors are not efficient enough or there is no visibility line to the vehicles. You can think about it using the following illustration. Imagine a human being trying to drive in a place they know well as opposed to a place they have never been before. Regular standard definition maps, you all know, will not do. An autonomous car needs a map that includes much more details, such as semantic information, road curvature, traffic signs, and everything needs to be in centimeters accuracy. It requires a map with semantic information, such as which traffic sign or traffic light is relevant to which lane, who gives way to who, the relations between the lanes, and much more. The map must be updated continuously so that when changes occur in the world, they are immediately visible on the map. It is very helpful to include in the map the actual drive pattern of the vehicles in given lanes, such as average speed or lane centering, which is not always according to the traffic rules, and in some cases, the lanes are worn out and cannot be observed. Let's talk a bit about terminology. REM, which stands for Road Experience Management, is Mobileye's solution for generating such maps on a global scale. And Roadbook is Mobileye's AV map product. It's the actual map itself. Let's look together on such a roadbook visualization on Europe scale. We start by zooming in on relatively small area, small junction. Please look at the richness of the visualization. We can see the lanes, the lane marks, the traffic lights, crosswalks, roundabouts, etc. And it then grows to a magnitude of all of Europe. This is what we are dealing here with. Okay. Let's talk about REM's data ingestion scale. So in order to generate a roadbook, we are using a crowdsourced technology where vehicle upload payloads containing the modeling of the road, driving behavior, and the surrounding of the vehicles. REM is working with many car companies, they are called OEMs, such as VW, BMW, Nissan, Ford, Geely, in production for several years now. This is a growing business. We are going to collaborate with much more OEMs in the years to come. We are collecting information of tens of millions of kilometers per day, and we operate at global coverage, United States, Europe, parts of Asia, China, Israel, and much more. In this visualization, we see the ingestion coverage. The video starts with a single day, and it then shows the coverage after 1 week, 1 month, and eventually 10 months. It basically illustrates that we have enough coverage to continuously map the entire Europe in relatively small amount of time. Sorry. Let's have a look on how REM works in high-level overview. Our relatively cheap IQ chips are spread around millions of consumer cars around the world, and they process images on the edge device itself. By using state-of-the-art algorithms, we create a model of the scene surrounding the location of the car. A multidimensional model of the road is created alongside all the signs, traffic lights, road marks, etc. This information is then being packed into a very dense payload, which we call an RSD, which stands for Road Segmented Data. RSD usually contains information from 10 kilometers, and its density is up to 10 kilobytes per kilometer, and so it means that every payload is roughly 100 megabyte of size. This RSD is anonymized, encrypted, and uploaded to the cloud, and while each of such RSD is a bit noisy, aggregating many of them using the REM technology from the same lane around the same time generates a centimeter accuracy of the lane. Mobileye invested a lot to make this process automatic in a click of a button on a global scale. And this roadbook is generated from crowdsourced, so its time to reflect reality after a change in the world is very small. The roadbook is then sent to the vehicle, which runs Mobileye localization technology that compares what the vehicle detects to the elements of the map. By doing so, the vehicle locates itself on the map in centimeter accuracy, and this enables autonomous vehicle driving features. Everything needs to be scalable, the harvesting technology, the APIs, the aggregation computation, which happens on tens or even hundreds of concurrent CPUs. And our approach allows us to generate the detailed semantic information I mentioned earlier. Let's talk about why we need an ingestion data lake. Each ingestion payload that arrives is kept in a data lake after intensive computation. Each record contains more than 150 attributes, containing things like events, geometries, time measurements, length of drives, specific events, metadata, and more. This data is later being queried for many use cases. The main use case is the roadbook creation. Every map creation begins with a query to the ingestion data lake, and we will drill into this use case a bit later in the next slide. But we also have analytics queries, so we can answer questions like how much time it will take us to get coverage of the United States highways. We also have UI tools so that our customers can see their RSD coverage. And we try to leverage this data lake and build new business models around it, such as smart cities and more. And this means that we have many internal customers inside Mobileye that need access to this data. And new types of usages are coming every now and then. Let's focus on the roadbook creation usage of the ingestion data lake. Our mapping process is done on geographical cells of about 10 by 10 kilometers. Every cell processing starts with a query to the data lake, scanning dozens of gigabytes and returning millions of records. This query happens, as you might guess by now, on Amazon Athena. Most of the queries are scanning 3 to 5 months of data, but some scan more. We sometimes generate multiple maps in parallel, and I'm not talking about mapping multiple cells in parallel. This goes without saying. What I mean by that is that we sometimes run multiple huge maps, such as mapping of Europe and another mapping of the United States in parallel, each containing multiple cells. We are using up to tens of thousands of such queries per day. Again, all of this activity is happening on Amazon Athena. In this visualization that we see, we can see a single mapping job of Europe running multiple cells in parallel. The small squares that you see are cells, and the map is generated by mapping multiple cells separately in parallel and stitching them together into a coherent map. Sorry. If you are wondering how we got to this level of analytics, I want to take a few minutes to explain how our journey with Amazon Athena, how we started with our ingestion data lake. This is a simplified version, very simplified version of the system we had back then. It begins with a vehicle that uploads payloads into a REST API interface used to retrieve the payloads. When a payload arrives, it passes some simple sanity check, and the computation plan is being built for it. It then being passed to a worker queue that executes the plan. This plan is very compute-intense process. It takes like dozens of seconds per single payload. At the end of the execution, we extract the 150 metadata attributes we mentioned that we want to keep in the ingestion data lake. The question that we struggled with back then was, which data lake engine can function properly and provide us query services to our use cases? So what were our requirements? We had to support joins on different tables, such as geometries of roads and stuff like that. So we have a relational data by nature. We need the data to be fresh so that every new payload that arrives should be available to queries soon after. We had the need to support geographical queries. And we wanted something that will be reliable and easy to maintain because this is a mission-critical functionality. We needed reasonable query speed. It doesn't have to be sub-second, but it should run fast enough for our needs. Like I already mentioned, we need to support a high concurrency of up to thousands of mapping processes in parallel. And we want the storage to be relatively cheap. Back then, our usage pattern was unknown, so we needed something that we can count on to keep evolving together with us. So what was the process that led us to choose Amazon Athena? It started with the design phase. Our initial idea was to use two types of system, one for the short-term storage, which was supposed to be more expensive but very efficient, and one for the long-term storage that was supposed to be cheap but not very efficient. And we had the need to start with the long-term storage, and our research led us to conclude that Amazon Athena together with Parquet files on S3 will work great for us. And we consulted our AWS solution architects, and they suggested that we will go to a data lab in Seattle. And we went into this data lab in Seattle and implemented a POC, and we then got back to Israel, and we finalized the implementation and went into production. As we were in production, the usage grew both from usage pattern, amount of data, and cost, and we had to do a few iterations of optimizations. The good news is that we were able to scale with Athena with our current storage strategy of using S3 with Parquet data format, and we don't foresee a need for a second system for a short-term storage and analytics. And putting things in perspective, the design phase took us 2 months, and the implementation phase took us 2 months, and we are in production for several years now, and with very small development efforts. It's nice. This is our current architecture, again, in high level, in very high level, without many of the small details. As you can see, the diagram is the same as the previous slide I showed. Up until the point, we have the 150 metadata attributes, and we use Kinesis streams, Kinesis firehose, and Lambda function in order to take the RSD metadata and convert it into Parquet files on S3. We run daily coalesce job to reduce the amount of files so we can increase the speed and reduce the S3 cost. And of course, Amazon Athena is the query engine that we use for all the use cases. So this slide is all about the optimization we have done during the time we are in production. Optimization is quite an iterative process. You are OK until something is not scaling correctly, and then you need to fix things. And we did few types of optimization. So the first type was query level optimization, where you look for better SQL statements for your queries. We also partnered with AWS to reach massive concurrency. We had to refactor our data models according to Amazon Athena best practices. And we started using new abilities of Amazon Athena when they showed up. For example, our typical query is usually filtering by geospatial and time. So by using a new feature of Amazon Athena back then called partition projection, we were able to add a geospatial partition, which uses tens of thousands of partitions per day, allowing us to get amazing optimization by reducing the amount of data scanned. In this optimization, we reduced the query time by 90%. We also reduced the cost by 90%. And it got us to 0 concurrency issues. And we can now query hundreds of concurrent queries instead of dozens. And we have 0 bottlenecks between different map activities, which was a very big pain point back then. And this is it. So we are really happy to work with Athena. And getting back to you, Scott.
Thanks, Ofer. Really fascinating use case. Every time I see the zoom out, I'm just kind of like, it's kind of mind-blowing. So yeah, really impressive to see the work you and the team have put into Athena. So and also the impact that it's had at Mobileye, being able to scale that really cool technology to many, many machines and devices out there in the real world. And that's something that I find is really cool about his use case. Is having been in analytics for a long time, it's kind of rare that we find these use cases where analytics goes full circle and ends up out there in the real world, powering sort of the decisions we make on a daily basis. So really cool. Switching gears now, we'll talk about how Athena is helping you bring all of your data together to provide you analytics on all of those sources. So when talking with customers about that topic, we often describe our thinking in terms of the modern data architecture for AWS and what it should do for you. A modern data strategy, as you heard this morning in Swami's keynote, kind of throughout the AWS reInvent sessions this week, the modern data strategy should give you sort of the best of both data lakes and purpose-built data stores. Again, thinking about all of the best-in-class database products that AWS supports. A modern data strategy should enable you to store any amount of data at low cost using open, standard-based formats. Modern data architecture should allow you to break down data silos, empowering teams to run analytics and machine learning workloads using their preferred tools, and giving you the capability to manage who has access to the data with the proper security and data governance controls in mind. Data lakes are often a great starting point because they provide flexible storage of data with high durability and low cost. And by storing data in open formats, you can decouple storage from compute. And that makes it easy when the time comes to analyze data by allowing you to choose the right tool for the job and bring a variety or choose from a variety of machine learning and analytics platforms and products supported by AWS. One of the benefits of data lakes is the flexibility to embrace new formats and paradigms for analyzing data. A recent shift in data lakes has been the emergence of table formats. Table formats, if you're not familiar, are gaining traction, mostly because they're really easy to understand. They allow interaction with data lakes with a familiar database-like constructs and semantics that allow us to abstract data from where it came and bring data into a singular data set represented intuitively as a table. One of the areas where Athena is leading the way is on its support of table formats. And last year at re:Invent, you may recall our announcement on Athena's support of one of those table formats, which is Apache Iceberg. Apache Iceberg is an open table format designed for very large analytic data sets. It has many properties, making it a great solution for data lakes. For example, Iceberg supports writing to data stored on S3. And that is something that many customers need as part of the operational activities that support their analytics programs. Iceberg also supports schema evolution, giving you add column, drop column, rename column semantics that look very similar to running a database. So those are very familiar to folks who are used to those paradigms. So we've not stopped innovating on Iceberg since last year, and in 2022, we've pushed the boundaries even further on what you can do with Iceberg and Amazon Athena. So to kind of recap some of those updates, the first of which is create table as select support for Apache Iceberg. So with CTAS, you get an easy and fast way to create new Iceberg tables from the results of another select query. We've also added view support, so you can now hide complex joins and other business logic, surfacing simpler to query analytic data sets that are surfaced to users to run SQL queries on. And we've also worked to optimize SQL queries running on Iceberg with Engine version 3. And we're happy to report that queries on Iceberg using Engine version 3 are running up to 10 times faster. And that's really exciting for those of us who are doubling down on the Apache Iceberg format. We've also extended ACID transactions in Athena. So you can now use Iceberg's merge operator to synchronize your tables as they're modified by other processes and business users. So that's going to make it a lot easier and efficient to keep your Iceberg tables up to date. Now, if you want to delete records to meet regulatory requirements like GDPR or to manage your storage footprint, you can now use the vacuum operator to do just that. And last but not least, we've also added support for Avro and Orc, so you can, giving you more flexibility to choose the format that works best for your use case and allowing you to bring that to Iceberg as well. So when scaling data lakes, it's really important to take into account not only the ease of use and flexibility benefits that we're describing here, but also the security and data governance needs that others in your organization most likely have. So we have some really great news on that front as well. And the news is that we've expanded our support through AWS Lake Formation to include all file and table formats currently supported by Athena. If you're not familiar with Lake Formation allows you to centrally define column, row, and table data governance policies, which when queried by engines like Athena and EMR, are respected. So users are only able to access the data that they're entitled to. So with this launch, you can now define all of those fine-grained data access and governance controls using Lake Formation and have those work on file or table format that Athena supports today. Best yet, we've implemented all of the filtering logic that was typically happening when these governance policies are applied during a user's query execution. We've implemented all of that natively in Athena's engine, so you're getting more optimized performance when users are querying their data lake files when Lake Formation policies are applied to them. Cool. So we're going to revisit the modern data architecture slide for a moment, as there's an important part of the story that we want to kind of build on. And that's actually the prevalence of data sitting adjacent to the data lake, oftentimes in databases, warehouses, or other object stores, often running in AWS, but sometimes on-prem or potentially even in another cloud provider. And oftentimes analysts, data engineers, and other users need access to that data just as they do their data lake. But too often those users are having to deal with the friction and frustration of having to learn new languages or build pipelines that extract that data and bring it somewhere else where they can then analyze it. Athena addresses this problem with what we call federated query. Federated query allows you to run SQL queries on data stored in relational, non-relational, object, and even custom data sources. Analysts can run federated queries using the same ANSI SQL syntax that we support for data lake queries and use that same language or a single query to join data spanning their federated sources with their data lake in a single query. With federated query, you query data where it lives, so there's no data movement. However, you can also use it to ingest external data into your data lake and use that to drive business intelligence and other use cases from your data lake without having to query all the way down to your underlying database each time. We have over 25 of these connectors available today, and earlier this year we released a bunch of new ones spanning cloud object stores, relational databases, and more. And in Athena, these connectors are really easy to set up and use. Starting with our console, you can click data sources and you'll see a list of all the sources that we support. And after selecting a source, you can follow our guided workflow to plug in the values that help you get connected. Our connectors work as applications running on AWS Lambda. And with that comes support for cross-account access and IAM policies. That makes it easy for one person in your organization to set up a connection and then grants access to other teammates so that they can then query that source using their own AWS account. All of our connectors are built on our open source SDK, and all of our code is out there on GitHub. So we hope you can take a look at that and use it as boilerplate code for any custom connectors that you're thinking about developing as well. This year was really big for Athena on that front and the data sources that we support. Altogether, as I mentioned, there's over 25 connectors available, often to some of the most widely used databases and storage platforms on the market today. Often that spans not only AWS sources, but third-party ones as well. And so another thing we want to sort of introduce here is the fact that many organizations today are using software as a service applications to help drive their businesses and sort of, in specific functions or use cases. Unfortunately, many of those SaaS data providers don't give you direct access to the underlying databases, which is a problem when you need access to that data to understand how your business is operating. One of our partner services is Amazon AppFlow. Amazon AppFlow is a fully managed integration service that enables you to securely transfer data between SaaS applications like Salesforce, SAP, Zendesk, Slack, and a bunch more, and bring that data to AWS and ingest it in services like Redshift and S3, where you can then use it for a variety of use cases. AppFlow supports over 50 SaaS sources, like the ones shown here on this slide, and that help you ingest all of that data and bring it to S3 for, again, a variety of use cases. The big news from AppFlow at this reInvent is their recently announced support of AWS Glue Data Catalog for data flows between SaaS sources and S3. What you can do now is basically select a SaaS source, build a data flow, and register that flow with AWS Glue. Once the data is registered with AWS Glue, you can run queries on it using Athena and a host of additional AWS analytics services as well. The AppFlow team went a step further and added a really cool feature, which is essentially partition setup as part of the flow design workflow. And what that lets you do is, as you're building your flows, select the fields using a simple GUI that allows you to sort of choose which fields in the response from those sources are good candidates for partitions to use in the data model once you're setting it up on S3. What that means is AppFlow takes that partition input into account when ingesting the data and automatically writes data to those partitions, which means Athena queries running on those sources are really fast. So we covered a lot of ground today. We figured we should kind of recap some of those things before we wrap up the session. So as you know, Athena is easy to use, giving you instant startup for SQL and now Apache Spark applications as well. That's a brand new experience in Athena, and we're really excited to see what you can do with that, as well as what feedback you have for us on where you want us to take that. So we encourage you to check out ANT209, which is happening tomorrow, to go really deep on that topic and learn more. We also covered SQL Engine version 3 and how it helps you with the expanded functionality for analytics capabilities that it provides, as well as faster queries. And again, on top of Engine version 3, we have query result reuse, which is available today and giving you faster queries at lower cost. Caching is a concept we're going to be investing heavily in, so I hope you keep your eyes and ears open for additional announcements on that front in the weeks and quarters ahead. We also touched on expanded support for Apache Iceberg and how you can now bring transactionality to your data lake and analytics workflows as well. So we're really excited to see what comes next on that. And as well as we touched on expanded support of row, column, and table level security controls powered by lake formation, and how you can now apply those policies to any table or file format that Athena supports. And last but not least, as you build analytics around your data lake, we encourage you to consider Athena's data source connectors and other services like Amazon AppFlow to help you bring all that data together. Wanted to thank you all for your time today, and thank our guest speaker, Ofer, for the insights and inspiration on their use case. And hope you got a great sense for the broad set of features that we've been rolling out this year and are excited to get back home and try them all out. So thank you.